This picture shows the Space Shuttle in orbit high above the Earth. Located on the nose of the Space Shuttle are the forward reaction control system jets, This picture shows the Space Shuttle being moved to the launch pad at the Kennedy Space Center. This platform can travel from the Vehicle Assembly Building to the launch pad in approximately 1 day at 1 mile per hour. This picture shows the Space Shuttle Columbia on its maiden voyage moving to the launch pad at the Kennedy Space Center. This is a picture of Columbia landing at Edwards Air Force Base in the desert of California after a lengthy mission. This is a picture of the U.S. Space Shuttle Discovery lifting off from Launch Pad 39 at the Kennedy Space Center. This picture shows a satellite located in the Space Shuttle's cargo bay. This is the first Space Shuttle mission, which occurred in 1981. Note the white paint on the external tank. This practice of painting the external tank was later dropped to save weight. The Space Shuttle is America's reusable spacecraft. It is America's workhorse and the only means for America to launch manned missions. This is a concept drawing of a space shuttle docking to the International Space Station. The shuttle will be used to resupply the space station during its time in orbit. This image shows the space shuttle with its cargo bay doors open, high above the Earth. The normal crew complement of a space shuttle is 5 to 7 people. This picture shows a space shuttle crew on the control deck of the Space Shuttle Discovery. This picture shows astronauts working in the Space Shuttle's cargo bay servicing a satellite. This image shows an astronaut conducting an EVA. This EVA was designed to test construction techniques for the International Space Station. This image shows the Space Shuttle being moved to the launch pad on the mobile launch platform. It takes approximately 1 day for the Space Shuttle to move from the vehicle assembly building to the launch pad at the Kennedy Space Center. This sunset photo shows the Space Shuttle on final approach for landing at the Kennedy Space Center. This is an image of an astronaut connected to the Space Shuttle's remote arm. This arm can be used for maintenance activities as well as construction of the International Space Station. This picture shows the Space Shuttle moments before it landed at the Kennedy Space Center. This picture is a cutaway view of a space shuttle in orbit, showing the space habitat located in the cargo bay. This picture shows servicing of the space shuttle after landing at Edwards Air Force Base. In 1981, Crippen and Young were the first space shuttle pilots to launch into space on board Columbia. This picture is of the Space Shuttle Enterprise, a prototype vehicle used for flight dynamics testing. This image shows a cutaway view of a solid rocket boosters which help the space shuttle into orbit. This image taken from a chase plane over the Kennedy Space Center shows a space shuttle after launch during its roll program.
Liftoff of the orbiter Challenger and the sixth flight of the Space Shuttle. The shuttle has cleared the tower.
Challenger's underway. We got a roll program.
Liftoff of the orbiter Challenger and the sixth flight of the Space Shuttle.
The Space Shuttle consists of three major elements: two recoverable and reusable solid rocket boosters, a non-recoverable external tank containing propellant and oxidizer for the main rocket engines, and the orbiter, the ship in which people and equipment challenge the elements of space. The orbiter is built primarily of aluminum and consists of three main components: the fuselage, the wing, and the vertical tail. The fuselage is divided into three sections. The aft fuselage carries the three main and two orbital rocket engines, plus the vertical tail. The mid-fuselage is the primary load-carrying structure containing the payload bay and payload bay doors. The delta wings are attached to the mid-fuselage. The forward fuselage includes the pressurized three-deck crew module with navigational, electronic, flight, and payload handling controls, as well as environmental systems and viewing windows. The orbiter's aluminum skin is covered by replaceable tiles for thermal insulation during the heat of re-entry.
Liftoff of the Orbiter Challenger and the sixth flight of the Space Shuttle. The shuttle has cleared the tower.
For medical and scientific research missions, the payload bay can be modified by integrating a laboratory module called Space Lab. Higher orbit or deep space probes can be put into a parking orbit with an inertial upper stage booster for on-orbit launches or deploys. Exiting through the airlock, crew members can venture outside the orbiter to perform a variety of tasks. Specially designed spacesuits are worn for protection. Individual manned maneuvering units are also available. Yet even as the human crew goes about its task, another system is at work. The same network of 5 onboard computers that precisely control the launch and orbit entry sequence also continuously monitor and control the onboard systems. For some functions, such as rendezvous, the system is designed to perform interactively with crew inputs. This system will also control the orbiter through re-entry until just before touchdown.
Liftoff of the Orbiter Challenger.
I believe that we're literally opening a new frontier in what man can do in space, and we'll be paving the way for many important operations on the coming space station, sir.
That is just great. You've really opened a new era for the world in space with this mission.
I believe that we're literally open. I believe that we're...
The overall length of the orbiter is 122 feet. It stands 57 feet high, with a delta wing that spans 78 feet. Cargo is carried in the payload bay. This compartment, 60 feet long and 15 feet in diameter, carries up to 55,000 pounds. Upon ignition, the shuttle will require more than 7.5 million pounds of thrust. Fed by the external tank, each of its 3 main engines generates 375,000 pounds of thrust at liftoff, while the 2 solid rocket boosters produce more than 3 million pounds each. The 2 pods on either side of the aft fuselage hold the orbital maneuvering subsystem. The fuel tanks carry nearly 24,000 pounds of propellant and oxidizer. Each engine is capable of 6,000 pounds of thrust.
I believe that we're literally...
We've gone for main engine start.
Stop aero program.
Go.
Roger, roll.
We've gone for main engine start. We've gone for main engine start.
Once assembly is complete, the entire shuttle stack, including the launch platform, is moved to the pad in the vertical position. It is carried on the same crawler transportation system which carried the Saturn V moon rockets to the launch pad. On the pad, the shuttle stands poised for its orbital voyage. At T-minus 6 seconds, the orbiter's main engines ignite. With the shuttle still bolted to the launch pad, the astronauts experience a twang effect as the stack sways slightly. Seconds later, the solid rocket boosters explode into life. The bolts release, and the shuttle rises on a column of flame toward orbit. During launch, the crew will experience no more than 3 Gs. 2 minutes later, with the shuttle moving at better than 2,700 miles per hour, the boosters are jettisoned for recovery at sea. At 8.5 minutes, the main engines cut off, and the external tank is jettisoned. It will not be recovered. At this point, the orbiter is at an altitude of about 70 miles. Once the orbiter reaches its highest altitude, the orbital maneuvering system boosts the ship into a circular orbit. This system also provides thrust for major orbital adjustment maneuvers, rendezvous, and deorbit, the burn to leave orbit and re-enter the atmosphere. To change attitude or point the orbiter, the reaction control subsystem is used. These small steering jets are also used for translations and as backup to the orbital maneuvering system. They are located in the 2 tail pods and in the forward fuselage. On achieving orbit, 2 Freon loops cool the orbiter's radiators, located on inner door panels to provide cooling for the orbiter systems. Without this system, the orbiter could only withstand 3 orbits.
We've gone for main engine start. We have ignition. We have ignition of the solid rocket boosters and liftoff. Liftoff of America's Space Shuttle, and the Space Shuttle has cleared the tower. We have ignition. We have ignition of the solid rocket boosters. We have
OTC, CDR's on the line.
CDR, OTC, good morning, Don. Let's do it today.
Sounds like a good plan to me, Bill. I'm for that.
Houston, Atlantis, MS1, contract.
Atlantis MS1, Houston, good morning. You're loud and clear.
That's great, and you're loud and clear also.
Roger that.
Good morning, Houston. PLT, com check.
Atlantis PLT, Houston, good morning. You're loud and clear. How many?
Loud and clear, Frank.
Thought you'd be higher by now.
So did I. Good morning, NTD. CDR here.
Good morning. How are you, Don?
Oh, we're doing fine. Al looks pretty out the window today.
Well, let's hope we get off today.
We'll vote for that. Good morning, Houston, from the CDR.
Atlantis CDR, Houston, good morning. You're loud and clear.
And so are you, Frank. Sound real fine for 8:45 in the morning.
Roger, we're ready in here.
Sounds good to us.
We have ignition. We have...